Hey guys, hope you're doing well. Here are the notes for day 18. All right, so we're looking the days Wednesday 5:13 and Thursday 5:14. Okay. Remember, guys, if you guys have any questions on this stuff, I know it's kind of difficult. Let me know. Shoot me a text or an email, and we can set up a Zoom to help you guys out if you have to. Okay. All right, today. All right, so we're going to look at three different type of functions, okay? So we've worked with linear functions, worked with quadratic functions, and worked with exponential. The whole idea of today's lesson is to determine what function you're working with, okay? So whether that's, if you have data in the form of points, or if you have story problems, or if you have whatever data you have, you can figure out what function best models that situation, okay? All right, so again, the three that we're gonna work with today: linear, quadratic, and exponential, all right? Okay, so here it says you may be able to use the graph of data points to determine a model for the data. Number one, all right, so what I did here to save some time, I already plotted these points, okay? So, excuse me, these three examples, A, B, and C, are visual examples, okay? Visual examples of looking at the general picture of the dots and trying to figure out what it looks like. So when I plotted these 6 points, I got this, all right? And you can see if I connect them, there you go, all right? So that definitely is a parabola. So we know that this data right here, these points, okay, model a quadratic function. Okay, let's go over here. So we have -2, 1, 2, 0.25. So that's right about there. Okay, -1, 1/2, 0, 1, 1, 2, and 2, 4, okay? All right, if I connect these ones, my graph is gonna look like that. Now, unfortunately, this graph is the whole reason why we're out of school, okay? This is very similar to the cases for the coronavirus, right? You guys have seen this in the news a lot, all right? We talk about flattening the curve. Okay, this is an exponential function. All right, the way I know that is that it starts off growing slow and then it increases at a faster rate. Then here, -2, 4, -1, 2, 1, -2, and 2, -4. All right, so these ones form a straight line. So that's linear. Okay, where you have to be careful, you guys, is, that you look at the whole graph. Like, for example, if I were just to look at this part from here to here of that graph, you may say, oh, it's linear, okay? Where if you take a step back and look at the whole thing, it's actually exponential. So you gotta be careful of what you're looking at there. All right, okay. A little bit of review here for you guys, kind of go into what we're gonna do today. Slope-intercept form of an equation, linear equation, y equals mx plus b. Remember, m is your slope, b is your y-intercept. Find the equation of a line given the points. Okay, so if I have 2 points, let's say that this was this point and that point, I can find the slope by finding that up here, finding that rise over that run, okay? So remember, you take the difference in the y values and the difference in the x values, and that's gonna give me 2 over -2, all right? So my slope in this example would be -1, okay? The y-intercept, if you look here, the y-intercept is y equals 3 or 0, 3. Remember, in order for it to be the y-intercept, the x-coordinate has to be 0. So the equation of this line would be y equals negative x plus 3. All right? Just by plugging in my slope, m, and my y-intercept, which is 3. We've done this before. All right, coming up with a linear equation. All right, second page. All right, you can also analyze data numerically to find the best model. Now, in real life, you guys, nothing is ever 100%. All right, but we look at what model or what function most closely represents the situation. All right, we do that by looking at the table of values. So if I have this table of values, all right, and I'm looking at what we call the first difference. So I'm looking at the difference in the y values here, all right? If you notice, okay, the x values are increasing by 1, and the y values are going up by 4, okay? So you see how this first difference, those values are all the same. That means that this is a linear function, okay? Linear function. And to find my slope, it's the difference in the y's over the difference in the x's. So in this case, we would have a slope of 4, and then fortunately I can look here and my y-intercept is 6. So I'd be able to come up with my equation, y equals 4x plus 6, and there you go. All right. All right, what happens if you look at the first difference and they're not the same? Negative 14, negative 4, 6, 16, 26. Notice those are not the same. Then what we're going to do is we're going to take what we refer to as the second difference. All right, if you look at the difference of the first difference, you notice that, hey, these are all the same. The second difference is the same. That is going to tell you that your example is quadratic, okay? Now, if it's quadratic, it takes a little bit more work to come up with the equation, all right? Now, if the second difference is not the same, okay, then this is neither linear nor quadratic, all right? Okay, so we're gonna use that information for example number 1 here, okay? All right. So first, we have to decide or figure out if this is linear or quadratic, because we need to use either y equals mx plus b or y equals ax squared plus bx plus c. Okay, we either have to use this one or this one, but we got to figure out which one to use. All right, so I'm gonna look at my table of values. All right, okay, so it looks like I'm going up by 3. I'm going up by 7. Okay, I'm going up by what, 11. And then this one, I'm going up by what, 15. Okay, so the first difference, okay, those are not the same. So we know it's not linear. Okay, it's not linear because that first difference is not the same. Now, let me look at the second difference. So the difference between 3 and 7 is 4. 7 and 11 is 4. 11 and 15 is 4. All right, that's a yes. So that tells me that this is quadratic. So easy that is. It's called the second difference. All right, and you have to make sure though when you're doing this that your x's are going up by the same amount as well, okay? All right, that change there is consistent. All right, so I'm gonna use y equals ax squared plus bx plus c. That's the model that I'm gonna use. Okay, so we gotta find a, we gotta find b, and we gotta find c, okay? All right, well, a couple things. I know what c is already because if you guys remember, my y-intercept That's the C value, okay? But I need to find A and I need to find B, okay? All right, so here we go. Steps for finding the quadratic equation. Step number 1, to find A, we take the second difference, in this case, which is 4, and we divide that by 2, okay? So that tells me my A value is 2. So you gotta kind of remember that. To find A, you take the second difference, divide that by 2. Number 2, the y-intercept will give you the C value. We already did this one. In this problem, 0, 3 is the y-intercept. So C is 3. We just did that. Now, to find B, we just substitute in A and C into this model, okay, with another point. So it doesn't matter. I'm going to pick 1 and 6 because I like those numbers. All right, so watch. So y equals ax squared plus bx plus c. Okay? All right, again, I'm going to use this x and y. So 6 is equal to, we said A, let me zoom out just a little bit. A was 2, so we got 2, and then x we said is 1 times 1 squared plus, we don't know what b is yet, times 1 plus 3. So all I did was I plugged in A, C, X, and Y. All right, so let's simplify. 6 equals 2 plus B plus 3. 6 equals 5 plus B. Subtract 5, and B is 1. Okay, so here's my equation. So y equals, all right, 2x squared plus x plus 3. All right, okay, let me double check. So I'm going to take my calculator to clear that out. Go to y equals, let's type in our equation here. 2x squared plus x plus 3. I'm going to go to my table, all right? And I'm going to see, hopefully my table looks just like this. 0, 3, 1, 6, 2, 13, 3, 24. Good. So I know that my equation is correct because it produces that same model, okay? Now, what I could do with this is I could predict, okay, if someone were to say, all right, well, what's the value at 7 when x is 7? You could use your table and say it's going to be 108, all right? Because that data follows that model. Okay, so you guys, that's how you come up with a quadratic equation. Those 3 steps right there. It's always the same way. Okay? All right, let's do another example here. Do the second one. All right, so let's look at, first of all, making sure that the x's are going up by a consistent amount. I'm going up by, what, 0.5, 0.5, 0.5. All right, so we know that this is linear because the first difference is the same. So y equals mx plus b is my model that I'm going to use. All right, okay. In this case, remember, my slope is that rise over the run. Okay, the first difference over the x's, so the y's over the x's. So my slope is 1/2. My b value, all right, is my y-intercept, and that is 1.5. So my equation is y equals 1/2 x plus 1.5. Okay? All right, now the steps down here are exactly what we just did. To find the slope, okay, the difference in the y's over the difference in the x's, which you already did here when you found that first difference. And we said that the slope was 1/2. The y-intercept, they gave this to us, all right? This was 1.5, so 1.5. All right, if for some reason this point was not on there, then what you can do is you can plug in your slope, which you found out. You pick a point, whatever point, it doesn't matter, plug it in for x and y, and you can solve for b, like we kind of did in the last example. All right, let's finish up, guys, with these last two examples here. Which kind of function best models the data in the table? Write the equation to model the data. All right, so let's look here. So first of all, the x's are going up by 1. And this looks like, be careful here, I'm going up by 3. I'm going up by 12. All right, looks like I'm going up by, what, 20, 23? And then 13, 40, 20, nope, 30, what? 34, 35, nope, 33. Let me just double check that, you guys, okay? But you find those differences. So 71, okay, 33. Yep. Oh, sorry, guys, that's what I was looking at. That's 13, the difference of 13 there, not 12. Okay, so if you notice the first difference, nope. So we know it's not linear, but the second difference, look at this, 10, 10, 10, okay? Aha, so this is going to be quadratic. And this is what your homework is gonna be like today. So I need to find A, B, and I need to find C. All right, in this case, good, they give us C, which is -1. Remember, to find A, we take the second difference and divide that by 2. So A is 5. All right, I'm gonna plug both of these in with, I'm gonna use 1 and 2. So 2 is equal to A times x squared plus B times x plus -1 or just -1. So 2 is equal to 5 plus B minus 1. 2 is equal to 4 plus B. Subtract 4. B is equal to -2. So my equation, y equals 5x squared minus 2x minus 1. And once again, guys, just to double check, never assume that you have the right answer. So go to y equals, clear that out, 5x squared minus 2x minus 1. So easy to make simple mistakes. All right. All right, so look at this, 0, -1. Can you guys see that? 0, -1, 1, 2, 215, 338, 471. Good. Awesome. Works. And the last one. All right, guys, the last one. All right, let's see here. So it looks like I'm going down by -1.4. Okay, let's just double check. Be careful. All right, so we have... Oops, let's go. Okay, so this is a negative. This is a positive 7. Okay, and then this is going up by 7. Hold on. I think that's 9.8. So, okay, so what you'll notice, you guys, is these are not the same. So it's not linear. And then if you take the second difference, what you're also going to notice is these will not be the same as well. All right? So from -1.4 to 7, and then 7 to 7, that's a difference of 0. And then there, here is a difference of, what is that, 2.1? So that's not the same. If you guys, if you come across that, and those are not the same, then it's going to be neither. It's neither quadratic nor linear, okay? If the first difference and the second difference don't come out the same. All right, guys, that's it for the notes. Your homework is on Schoology. Make sure you guys get that done by Friday. Appreciate your time. Hope you guys are doing well, and we will talk to you soon.